Well, good morning, everybody. How's everybody doing this morning? I'm told I talk loud, so hopefully I'm okay. Everybody can hear me okay? I don't need the microphone, which was given all the back feed and what have you earlier. We're good? You guys can hear me back there? Okay. Or you don't, or you can't, and you're happy because you can take a nap. Either way works for me. All right, so good morning, everybody. Let's see, is this going to work for me? Oh, is it? It works when you test it, but then it doesn't work when you need it. Okay, we don't. So, as Mark mentioned, today there are two topics I'm going to be talking about. One is crosswalk optics, which I understand you had a very good presentation on crosswalks this morning already, and also lighting controls. So we'll get right into it. First off, I'm not going to go through this in detail. All this really says is I'm old, I've been around for a while, and you have some reason to believe I know what I'm talking about. So we'll move right past that. Into crosswalk lighting. So, not a good chart, right? Since 2010, pedestrian fatalities in the United States have gone up dramatically. You may have seen some statistics around this earlier this morning. I'm not sure or not. Anybody know what happened around 2008, 2009 timeframe? Cell phones, yeah, smartphone, in particular smartphones. And what we've seen is a significant increase in pedestrian fatalities, more significant than accidents have increased. So it's a concern after years and years of it declining. And there are a number of strategies that folks have taken to try to address this from a daytime standpoint. Things like painted crosswalks, painted alerts, because what are people doing when they get to the crosswalk, right? They're looking down at their phone. So you're hoping that if past their phone, they see this alert to say, hey, you're about to step into traffic, right? Increases in signage, adding speed bumps, a lot of daytime activity, tactics around helping to reduce pedestrian accidents, pedestrian fatalities. But behind the data, what we see is what has really increased is nighttime fatalities. And you can see from 2010 through 2021, the gap between daytime and nighttime fatality has increased dramatically, gone to 3 to 1 to almost over 4 to 1, right? So clearly, some of those strategies aren't going to help us at night. We need to do something with lighting. So big surprise, there's a lighting guy here talking about how lighting can help solve problems, right? So when we look at the IES, and this is just kind of the high level, and we talk about crosswalks, the IES recommended practice suggests, based on the amount of pedestrian activity, different light levels that should be provided in those crosswalks. The key thing here, and what is often a gap when we are addressing crosswalks, is that this recommendation is based on vertical light levels, okay? Not horizontal light levels. Because when we think about a pedestrian walking across a crosswalk, that's pedestrian is a vertical surface, right? So we need to see that pedestrian. If only way we'll see that pedestrian is if we're actually putting light on the pedestrian. And the standard requires a calculation at 1.5 meters or 5 feet, about yay high, and the orientation in both directions if it's a two-way street, right? If it's a one-way street, the calculation only needs to be done in facing the oncoming traffic. But in a two-way street, you have to do two separate calculations for each side of the street. So you are lighting vertically from both directions. All right. Standard lighting distributions, like you see represented here, aren't really designed to provide high levels of vertical lighting. Can they? Yes, if you take care in terms of where you position fixtures that have traditional lighting distributions, you can achieve some decent vertical illumination, but that's not really what they're designed for. They're really primarily designed to light the ground, right? And the traditionally approach to lighting crosswalks tends to look something like this, often without the markers indicating that there's a crosswalk there. But here you can see the crosswalk, would everyone agree that the ground looks to be pretty well lit there, yes? Right? The light fixtures are typically placed on either side of at the ends of the crosswalks, right? And lighting the ground. The problem with this type of approach is it doesn't do a very good job of lighting people in the crosswalk. It creates a negative contrast where the person is dark against brighter backgrounds, which is not the best scenario from a visibility standpoint, okay? In addition, car headlights have evolved over time. Now, if you have your high beams on, as we all know, when we're driving on a rural road, our high beams on, we can see stuff in the distance. You can see, you can see good vertical surfaces, whether it's a deer that's off the side of the road about to hopefully not jump in front of you, but you can see it in advance. But when we're talking about crosswalks, we're not typically talking about a situation where your high beams are going to be on. They're going to be your low beams are going to be on. And, you know, as many of us may have observed, especially any folks like myself getting a little bit older, headlights have changed, right? They're getting a little more better defined, right? The distributions coming out of headlights are more tailored, right? So there's not as much scatter. Now, from a glare standpoint, that can be a challenge, oncoming drive, right? But from a visibility standpoint, because those distributions are more finely tailored, we lost a little bit of that scatter light that was helping us, right, in terms of our vertical visibility of vertical surfaces. So with all these challenges, Acuity recognized an opportunity, and within our Cyclone product line, developed a whole new optic specifically designed to address crosswalks. So what this is it's a light engine. Okay, so a light engine is the part of the light fixture that's inside the light fixture that actually produces the light, and it's a light engine that is designed with a specific optical distribution tailored for crosswalks, and it's intended to be used on both sides of a crosswalk. Again, in a two-way traffic. If traffic is one way, you only need to put it on one side of the street, and it can handle a variety of widths of crosswalks as well as length of crosswalk. The idea is to maximize the vertical illumination on the pedestrians and minimize glare for oncoming drivers, which also can interfere with your visibility of seeing those pedestrians. And the way to apply it, it kind of looks like this. So here you see the lighting distribution on the ground, and you will note that the poles are on either side of the crosswalk. This is a two-lane or two-way traffic on this particular street. And the poles are upstream, right? So the poles are not located directly behind the crosswalk or right next to the crosswalk. The poles are upstream about 10 to 12 feet. And ideally, for this particular two-lane road, the pole height would be about 15, 16 feet tall. And the idea is that the distribution of this light fixture, which as you can see kind of from this ISO foot candle plot here, pushes the light both this way and this way and gives you a result. The idea is to light that vertical person walking across the street. So in that previous picture, we go from a negative contrast to a positive contrast. We have much better visibility of that person that's walking across the sidewalk. Or we go from a situation like this to a situation like that. The examples you've seen here are all for mid-block crosswalks, which are often some of the more challenging ones because they tend to be the ones that are overlooked the most when you're lighting crosswalks. Intersections usually pay a little more attention to just by default, right? But the same optical distribution can be used at both mid-block crosswalks as well as crosswalks that are located at intersections. Because it's a light engine, that light engine, the fixtures that this optic is available in is any fixture that uses that particular light engine, which from our Cyclone product family are all these different styles of fixtures. So a wide variety of fixtures, any one of which can be is provided with that crosswalk lighting distribution. The nice thing about that is that you can kind of blend the lighting that you're using on the rest of the street with the lighting that you're using adjacent to the crosswalks if you should desire to. And the casual observer that's looking at the street and the aesthetics of the street wouldn't know that there is a difference, right? And certainly during the day in particular wouldn't know there is a difference. I'm sorry?
Make a solar application?
Man, I just okay, sorry. Mark, give that guy $1. Sometimes there are challenges, right? When you're going into locations where, you don't want to tear up the concrete or there's not power readily available. Many of those luminaires are available with a solar option, where you could use it with a direct battery pole and plop that light fixture right in the location you need it to without having to run conduits or, trench up the roadway or the sidewalks or what have you. You ready for, what my next slide is? No. Okay, just checking. The They also can be incorporated with controls, right? So you can, you could set it up, and we were just talking about this earlier. I live right near a university that I have to drive through quite frequently getting to my home. And the main road that runs through the university, there's about 4 crosswalks. And, the students in that university are very, very well trained to know as soon as they walk up to the crosswalk, they push the button because they know that button lights start flashing and it alerts the drivers that they're coming across. So you could do the same kind of thing with this lighting overhead. You could actually tie them into the same control switches so that it would kick, if you should want to, it would kick on the lights when someone is actually going to walk into the crosswalk. There are some companies that have tried to do crosswalk lighting incorporating motion sensors, and that hasn't worked out quite right yet. Because it's difficult to distinguish between cars and people, and now you got the lights are turning off and on. So my recommended approach is to either stick with this like a button control or to have them just be on all the time at night when you're lighting the crosswalk. Okay. Yes?
The solar panel, does it give the full lumen output of a normal electric system, or is it?
Yes.
So it can light just the whole roadway is just.
Yeah. With our solar systems, we're lighting roundabouts and parking lots and now are you lighting it to like retail lighting standards of 5-foot candles or whatever? No, right? Not without a forest of poles, but for light levels associated with crosswalks, you're even up to your 40 lux, you can provide that as well as general street lighting. And like I said, we're doing. In a number of states out in the Midwest, we're doing roundabouts because they have these roundabouts in relatively rural areas, and they don't want to there's no power. It just makes an easy way to light the roundabout. We actually, I think if I'm not mistaken, Mark, we have a solar setup in the trailer outside?
Yep.
So if you want to get a sense of how, it's tough from pictures to get a sense of how big those are, but we have one of the setups out in our trailer outside. Yes, sir?
Where do you mount the batteries in the solar system?
There is a box. I'm not sure if you can see it. You cannot because it's behind the panel. There's a box behind the panel where the batteries are located. You got the wrong angle of that picture to see that. Okay. So speaking of controls, this is my segue into the controls part of the presentation. Any other questions on the crosswalk optic? Okay, good deal.
Have you
Yes, sir.
deployed the pedestrian-activated lighting in other words, when somebody pushes the button that it then lights up the roadway?
We
you
have
guys deployed
not yet had anybody do that. No. It is an option, but no one's pretty much everyone we sold crosswalk optics to have had them on dusk-to-dawn. Yes, sir.
Do they steer away from that just because of citizen errors, like not pressing the button?
I think that's one of the primary concerns is that they don't want to they don't want somebody to walk out into the intersection not thinking to push the button. It's one thing on like a college campus where it's traffic all day and they're pushing the button all day just to get the flashy light to go so the traffic will stop. But that's, I think, one of the primary concerns. They don't want to leave it up to chance that somebody might walk out into the intersection on their phone, right, without pushing the button to activate it.
So that's interesting, because with RFPs, we're doing that, to get the flashing lights to go off. But the latest rounds of RFPs that we put out also have lighting associated with them. And the lights don't come on unless somebody pushes the button.
Yeah.
So I don't know why people are that scared of it. We're already doing it in a lot of places.
I think a lot of the time we did a project with Georgia Power in downtown Atlanta, and the pedestrian-activated lighting was a secondary light. So they had lighting that lit the roadway, but that when somebody pushed the button, it brightened up the crosswalk, and that actually, we found that your eyes were more drawn to that extra light than it was even to the RRFEs. That's
Right.
what they found out there, is they say people just saw the pedestrians because, just the ambient, the other lights from the street lights around the area lit up the pedestrians, but when those lights came on right above there and really, really bright, everybody went, whoa, there's an actual pedestrian there.
Right.
So I think you have to do it you've got to have some kind of lighting level around there for when somebody doesn't press the button.
Yeah. Yeah, and generally speaking, these lights, the crosswalk lights are in addition to the lighting that's for the roadway itself. Now, one of the things that we can do that's somewhat unique is we can incorporate the crosswalk lighting optics into a Luminaire alongside roadway lighting optics so that we're both doing both jobs at once. Now, currently, it's either off or on, right? So you've got everything on or everything off. In the not too distant future, we're going to have the option to where the roadway lighting optics inside the Luminaire will be on dusk to dawn, but the crosswalks will have the option to be controlled, turned off and on via an external device like a switch. And exactly to your point, the argument, one of the primary arguments for it is it's that change. That change alerts a oncoming driver that something's happening. I need to pay attention here, right? Whereas if it's always that, if the light level is always on, people will tend to get accustomed to it. And then that's the opposite of what you want to have happen. You want to increase their awareness and their alertness. So thank you. Good questions. Good over here. Appreciate it. All right, so let's talk about controls. So before I talk about controls, I need to talk about some what I'm going to call enabling technology. How many folks here have heard of DALI drivers? Okay, a few, not many. I'm not surprised by that. DALI drivers were first introduced in Europe maybe, I don't know, 10 or so years ago. Everybody's familiar with the standard driver we see in LED luminaires, right? 0 to 10 volt, okay? The primary difference between a 0 to 10 volt driver and a DALI driver is that a 0 to 10 volt driver is analog, a DALI driver is digital, right? So at a very basic level, a DALI driver handles dimming much, much better than a standard 0 to 10 volt driver. You can dim to 0, you can dim at specific increments from 0 all the way to 100. And that was the initial benefit of going to a digital driver as opposed to an analog driver. DALI is now in its third generation. Why generation 3 is D4i, I do not know. So I can't answer that question. But for whatever reason, the third generation is D4i. Yes, it was a joke. It's part of my spiel. You're killing me here. All right. So with the DALI drivers, it's in the third generation, and it is D4i because of essentially the Internet of Things. All right, we're trying to incorporate additional technologies, and in each evolution, it has added additional capabilities. So that's a little bit of an eye chart. I'm going to summarize kind of what DALI drivers do. First of all, as I mentioned, it is digital, so it does provide benefits from a standpoint of dimming. But what DALI drivers also do is provide power. It's low voltage power, but there are two buses on the DALI driver. One to provide, there's an integrated auxiliary power, and there's also a dedicated 24 volt auxiliary power that can be utilized by something else, not the fixture, okay, by something else. I'm going to have to watch you now. The whole rest of my presentation, I'm going to have to watch you. DALI drivers also have the ability to have memory on board. So you can so it can store asset information. What's asset information? Asset information is a fixture catalog number, it's wattage, it's the color temperature of the LEDs, the date it was manufactured, all sorts of information about the luminaire itself. It also can do energy monitoring. The driver can actually measure the amount of energy that the luminaire is consuming. And it can also do diagnostic and maintenance, has diagnostic and maintenance capabilities. Okay, it can track burn hours, for example. So it can give you alerts and say, hey, this fixture's been burning 60,000 hours. We're getting to the point where you may need to think about, replacing it, right? Because it's reaching its end of life, if that happens to be where that end of life is. So that is the basics of a DALI driver. Okay, very high level. Yes.
How widely used is it in the United States? I know in Europe it's very widely used, but I don't think it's as widely used yet.
So you are absolutely correct. We're seeing it more and more, and the reason we're seeing it more and more is what it enables us to do. Where we're seeing it more and more, for example, right now we're doing a project with the City of Philadelphia, over 100,000 streetlights, all with DALI drivers, because they're taking advantage of, for example, the asset data. Because all the fixtures come with all the information about the fixture loaded onto the fixture, as soon as the contractor installs that light fixture and connects the control device to it, all of the information about that fixture is automatically uploaded to the city's network. There's nothing that has to be done in the field to capture any of that information. So from an activation standpoint, installation standpoint, just that one feature alone is saving them money and time at every installation. But they're also taking advantage of some of these other features as well. And we're seeing it more and more and more. And when we get into some of these controls, you might understand why that is.
Quick question.
Yes.
So we know a lot of municipalities are buying into it. Have you had any full DOTs buy into it and go system-wide?
Not DOTs yet, no. Nope.
We had like New Jersey Turnpike authorities, they have 20,000 lights, it's not DOT, but it's large. But we're just putting the D4I drivers in every light as a proactive measure, knowing that in time, we are going to, in a network everything. So it's like it's coming.
A question would be, if you've got, because I know there's a lot of smart NEMA 7-pin nodes that you can use. They've got cellular, that can do the dimming, that can do the control, that can do the power monitoring and all the rest. I know there's, on the 7-pin, if it has a DALI driver, you can also connect to it and you can get additional information. But what is that additional information if somebody's putting a smart node on with the DALI driver? Like what else?
The primary thing is you get the asset data, but you also get the diagnostic data, so burn hours and things like that from the Luminaire itself. Now in some network controls, it'll be a duplication, right? Because some of those network controls will measure some of those same things. In some cases, more accurately, like DALI driver standard for energy measurement is plus or minus 2%. There are several network controls out there that are plus or minus 0.5%, which is an important distinction because from a utility standpoint, most utilities require for energy metering quality to be plus or minus 0.5%. So there is some duplication if you have a network lighting control on top of a DALI driver, but you can do a lot with the DALI driver by itself if you don't initially need that network lighting control, which we'll get into here in a minute in terms of other alternatives around controls. So, let me go back to this here real quick. Where'd it go? Here it is. So one of the things that a DALI driver enables us to do is change the way we control luminaires. Now, traditionally, we've controlled luminaires, outdoor luminaires with photocells. Photocells are AC devices. Okay, they're actually switches. So as switches handling AC power, they have to have components inside of them that enable them to both switch to power and handle that power, right? And what you see on this screen here, right, on the left-hand side is an image showing all of the different components of a standard photo control, AC-based photo control. When we have a DALI driver, the DALI driver can act as the switch. We no longer need to rely on an external device to actually act as the switch. As a result, we could change the actual control, which becomes just a device to let the DALI driver know it needs to switch, strictly to DC. We can strip out all of the components that are required for AC power from the device. So what does that do for us? So now I will say this, Acuity through our dark to light brand makes the best photo control that you can buy in the market, period. And I will argue that any day, not right here and now, but I can support that argument. Even with our photo control, by taking out the AC components, the DC version is much more reliable. Less power going through these components, they'll last longer. Okay? So now we're taking advantage of the DALI drivers by eliminating the line voltage through the control and making it a more reliable control. What's the thing we replace most frequently with outdoor lighting fixtures that are switched by photo controls? The photo controls, right? So we've just made a photo control much more reliable. So that's one benefit we're getting from DALI drivers. So we're all familiar with our 3-pin. Most of us by now are familiar with the 7-pin photo control. We've added the 4 contacts, which are low voltage contacts, which allow us to connect to the dimming leads of a 0 to 10 volt driver or connect to an external sensor perhaps. With DALI drivers, though, we don't need a 7-pin or a 3-pin. Now, DALI drivers can be used with 7 pins, right? We don't have to stay away from 7 pins with DALI drivers, but we can go to what's called a Zaga receptacle. So what is a Zaga receptacle? Simply put, a 3-pin receptacle has AC power. The 7-pin NEMA receptacle has AC and DC power. The Zaga gets rid of the AC, is just DC. It just has 4 DC contacts. Okay? So it's designed specifically to work with DALI drivers where you no longer need the AC power to flow through the receptacle. Make sense? Easy peasy, right? So what does that look like in a Luminaire? This is what happens when you take your high school engineering, your high school daughter who is in an engineering program and say, hey, listen, can you put a slide together for me that looks like this? I think she did a pretty decent job, actually. On the left-hand side is a typical Luminaire setup, right? So you have line voltage coming in. It goes through the receptacle to your surge protection device, driver, light engine, right? This is what it looks like with a DALI driver and a low voltage control. Your power goes directly to your SPD and your driver. If you have you can still have a photo control, but it's a low voltage control. You can also have additional devices attached to your Luminaire. And what the driver does is can communicate to both of these. So it's two-way communication, as well as provide power if those devices should need power, right? Photocell up top wouldn't need power, but it would need to communicate to the driver to tell the driver it's dark out, turn on, or it's light out, turn off. But maybe you have a sensor down here where you're providing power to the sensor, and the sensor's providing communications back to the DALI driver, right? So understanding now we have DALI drivers, we have low voltage controls, and what they could do for us, that sets me up to talk about controls. So first off, the first thing to remember with controls is the more functionality you add to a control, the more cost you add to the control, right? So your basic bottom left-hand side is your basic on-off photo controls. Top right-hand side is like a fully networked, all the bells and whistles type control. There are cost implications associated with that. But what are the types of functions that you can have with controls? This lists of the types of functions, from everything from dusk-to-dawn, as I said, to fully networked. Things like controlling groups, things like scheduling, monitoring, asset management. There's all these are different types of functionalities that can be built into controls. Now, one of the things, I don't know if we mentioned at the start of the presentation here, so Acuity Brands is the largest lighting fixture manufacturer in North America, just shy of $4 billion in sales, which makes us as big as our next 3 competitors combined. One of the good things about being one of the biggest is that you got a lot of options. One of the bad things about being is that you have to deal with all these different options and figure out how to apply them in the right place and time, right? But it puts us in a great situation when we're interacting with our customers because we could fit our customers into the solution that best matches what their needs are. We don't have to fit them into our solution, okay? And that's the thing I like the most about having all of these, as confusing as it can be, having all these different options. And what you can see is that so the functionality is across the top. As you go down, you'll see more stuff filled in, right? So you're talking about basic controls all the way to fully networked controls. And we're going to give you a kind of a quick tour, as I look at my cheater here, a quick tour through our offering of controls capabilities. So it starts with basic on-off controls. As I mentioned earlier, we have AC/DC. We have both our traditional DC or AC-based photo control, which is, if we all remember, the best photo control you can buy, hands down. And if anybody wants me to challenge on that afterwards, I'd be happy to. As well as DC versions. Now, our DC versions come in 2 versions. One is this guy, which is much shorter than the AC version, less stuff inside, that plugs into a Zaga receptacle. It's designed to work specifically with the DALI driver and the Zaga receptacle. We also have a version here, which is a hardwired version. So what this enables us to do, I'm going to go back to that in a second. What this enables us to do is provide a light fixture out of the box with the photo control already installed. So all as an installer has to do is mount it to the pole, connect to your power, and you're done. It's dusk-to-dawn fixture. It's operating. Nothing else. No extra hardware to order. I know it takes only a second to twist that thing in, but you don't have to worry about it. And does it get twisted in properly? It's out of the box. It works. No fuss, no muss. Nice and easy. Here's the great part about this story here, right? You want to guess? I'm going to cause trouble for Mark here. I know. Cost-wise, fixture with a standard photo control, fixture with a DALI driver, and a DC-based photo control. Which one are you going to pay more for?
AC.
AC. Everybody think, yeah, that sounds like the most likely case? Mark, which one they're going to pay more for?
DC.
Yeah. The hardware, just the material cost alone is more here, not to mention you also have to spend an extra couple of minutes to install this guy here, as well as manage different packages and stuff. But from a material cost, we got a better solution at basically essentially a lower cost.
So if that one with the photocell wired in goes bad, does that whole receptacle have to come down and go back?
You replace the whole Luminaire.
Right.
Yep. But what you have here is a 20-year fixture. This DC control is actually not your shortest life component in the fixture anymore. Your shortest life component in the fixture is now the driver. So the fact that that's embedded really doesn't change your maintenance cycle, because what's driving your maintenance cycle with the embedded DC control is the life of your driver. And the driver you can replace. So I want to go back to something real quick, if I can. So I have this little image here. One of the things we also do with DC is it's not unusual for folks to have adjustable output fixtures, right? Some folks do that with switches on the drivers. Some folks do that with an additional device that goes inside the Luminaire, adjustable output module, if you will, where you can fix dim the fixture. And there's a lot of reasons for doing that. One of the challenges with that, though, is if you have a fixture that you have one of those, if either controlling it via an adjustable dimming device or on the driver itself, is that if you in the future want to go back and install a network control, it won't work exactly the way you might want it to. And the reason is that when you use a dimming device inside the fixture, that takes up the 0 to 10 volt leads in the driver. And if the 0 to 10 volt leads are no longer connected to the receptacle. So if you want to use dimming with that fixture with the network control, you actually have to rewire the fixture in addition to put the network control on the Luminaire. One of the neat things about the DC controls are the fixed dimming feature is actually built into the control. So in the case of this fixture here with the DC control, if you were to replace that DC control with a networked control, the network control will work exactly as it was intended to in terms of dimming, because you haven't changed the wiring at all. The wiring still goes into the receptacle, and the device that was controlling this fixed dim you just removed. So it's a nice added benefit in terms of future proofing, if you will, the Luminaire. So I'm going to go. So this is a whole brand new product we have, relatively speaking, called Local Connect. So this again takes advantage of the DC control technology, but what it adds in is Bluetooth communications. And that Bluetooth communication adds us to do a couple of different things. One is, and I'm going to just jump to this slide here. So one is that through an app on your phone, you now can communicate with that light fixture, and you can capture all the asset data that's on the DALI driver. You can also, through using your phone, capture the GPS coordinates of that Luminaire when it's being installed. So from an asset management standpoint, you now know what you have and where it is and when it was installed. Okay? Now this is not live communications in terms of it is not networked. So the only time you can communicate with this fixture is when you're within 100 feet of it and you have the app that you've gotten into via your password. Okay? But what it does is it captures all that information and uploads it to a web portal, so that back in your office, you can see all that information on a map. Again, it's a static map. Okay? The information in the map is only current as of the last time you communicated with that fixture. But what it does is it gives you asset management capabilities. You know what you have and where it is. You know when it was installed. Anytime you go out in the field to connect with the fixture, it will update that information. Okay? So you can get updated information in that way. But you can also program dimming profiles. So say, for example, you have this fixture on a street where you want to you want the lights on full power at dusk through maybe midnight, and then you want it to dim to 50%. You can program that profile into the fixture, and it will keep operating that way for as long as you have it there, or until you go back out and change the programming. You can change, since it's all done via Bluetooth, you can change the programming you don't need a bucket truck, you don't need a ladder, you can do it from the ground. You can do it in batches, so any fixtures that are within 100 feet of where you are, you can do all at one time. So it's a nice it's an intermediate solution for someone who does not want to make the investment for a fully networked solution, but would like the benefits of asset management and would like the benefits of being able to have some additional control beyond just dusk to dawn. right? Think about like a park, right? Where, you know, a athletic park of some kind, you might want to shut the lights off after midnight or 1 o'clock. That gives you the ability to set those kind of profiles. And if you want to change something, it's relatively easy to go out in the field and change it. So again, not a network solution. So the communication is not live, but it does fill a gap kind of between the dusk-to-dawn controls and a network solution where you can have the fully functional capabilities. All right, so one of the other nice things about Local Connect, so typically Local Connect is located on the bottom of the luminaires. You see here in these 3 images. There are 2 versions of Local Connect. One is just the dusk-to-dawn control, right? The other is where you can have all the control options. This is where you can upload lighting profiles to the fixtures so that they can operate dimming at different times of night, okay? One of the neat things about Local Connect is embedded, right? So it is hardwired into the light fixture. You do not attach it in the field, it's hardwired into the lighting fixture. But if you get the fixture with either a Zaga or a 7-pin receptacle on top when you purchase it new, if down the road you should install a networked control into that receptacle that's on the top, Local Connect is programmed such that it will say, hey, somebody else is in charge. And it will relinquish control of the luminaire to the device that's connected to either the 7-pin or the Zaga receptacle. So from a standpoint, if someone starts out with Local Connect and the basic functionality that this offers, but maybe 4 or 5 years down the road says, we'd like to go with a networked control. They can attach the network control. The network control will take over the fixture. The Local Connect device relinquishes control, and there's nothing you have to do with, in terms of wiring the fixture, anything. It does it automatically. I think nice, kind of a nice little feature in terms of future-proofing the luminaires. So next we get into NLight. NLight is a little unique, and it's almost like I have to step aside with NLight a little bit because it is more than just an outdoor lighting control. Actually, let me go back here a second. So NLight is actually a family of controls, and it can do everything, right? So no matter what kind of lighting fixtures you have, NLight we have the ability to control them. And the interesting thing about NLight is you can kind of build on it, right? So you can have NLight controls on a device, it just controls an individual luminaire, right? Whether it's an inside luminaire like you might have here, or it's our parking lot lights outside or roadway lights, it could just control that specific luminaire and that's it, okay? NLight can also control groups of luminaires so they operate together in unison, all right? But with some additional hardware, NLight can be managed time schedules. You can access it remotely, so you can manage schedules and things like that through a web interface. So it's really a very broad-ranged lighting control solution. But from outdoor types applications, here's a kind of a typical application for NLight. So first I'll say NLight is not typically something you'd use on a roadway. Okay, but NLight is something you would definitely use in parking lots and office complexes, things along those lines. So here's a typical installation of NLight where you have a building here with walkways coming from several parking lots. There's another building over there with a walkway going to that parking lot, and each one of these icons is a luminaire, and each one has an NLight device in it. One difference is that the ones on the end here have motion sensors as well. Okay, so at the end of each walkway, there are motion sensors. So these fixtures are set up as multiple groups and intended to, so in normal operation, if no one's out, the fixtures turn on at 50% power. If the motion sensors in any one of these zones, so if a motion sensor here picks up motion, all these lights go up to 100%. Now, we could also program it, that motion here, so actually, I'll tell you what way it is programmed, right? So you come here, this yellow group of lights go up to 100%. If you come from this end, this group of lights go up to 100%. If you come out the front door, both sets of lights go up to 100% in anticipation of not knowing which way the person's going to turn when they walk out the door, but illuminating both directions. And there's any number of combinations you can do that with. It can also be extended into very large areas. Fixture to fixture, you have 1,000, I think it says here, 1,000-foot range from fixture to fixture. Fixtures can also convey messages down the road to extend that distance further. Again, not a street light application for this type of control, but for parking lots, for for roadways around office parks, things like that, for college campuses, very, very well suited to do it. And as I mentioned, for NLight is everywhere and everything. So we have NLight, the ability to put NLight controls into any fixture that can go inside or outside of a building, as well as all sorts of accessories that are NLight accessories that can control these lights, whether it's switches or sensors, daylight sensors, motion sensors, all sorts of different switches, security switches. It's a very, very broad range of products that NLight is available in. So finally, the last set of controls is the fully networked lighting controls. And we have a couple of them ourselves, but all of our fixtures can handle any third-party network lighting control. By network lighting controls, this is where you have active communication between the luminaire and a network. It takes form of either two forms, either radio mesh, where the fixtures are communicating to each other via radio frequency, or cellular, where the fixture itself is communicating directly back to the network, just like a cell phone that you have, right? We have both DC-based controls as well as AC-based controls. We do in conjunction with a company named Itron, and that is a radio mesh solution. Very, very popular in the utility world because Itron also does a lot of metering, like water meters, electric meters as well, with their radio mesh system. As well as Ubiquia, which is a cellular-based solution. Both Ubiquia and Itron come with web interfaces that allow you to interact, manage your lighting, control your lighting, with Ubiquia, we have both an embedded solution similar to the embedded DC control that we have, but with a network capability. It's got a cellular capability built in, as well as twist lock solutions for both of those as well. And our fixtures, this is images of our Cobra heads, but as most our fixtures are available with all the different connections. So whether you're talking Zaga receptacles on the top or on the bottom or both, or NEMA on top or NEMA on top, Zaga on bottom, we can provide all sorts of different combinations. In Cobra heads, not every fixture lends itself to being able to provide two connection points. Area lighting fixtures like Cobra heads and such do. Some of our other fixtures, you have to make a choice, right? Either embedded or Zaga or NEMA. And now it's the same chart and with the additional information in terms of what the different product groupings are. So I'm going to go real quick to say, so from a Cobra head standpoint, and it is true of many of our area lights, we can accommodate any of those different controls capabilities. So whether you're talking about NEMA receptacles, right? We have a variety of different options from regular dusk-to-dawn to our NLight to a networked control, whether you're talking Zaga options with low voltage controls, or whether you're talking embedded solutions. We've got a pretty wide range. We can get you the fixture in just about any way you would want to get it. So I just gave you guys about what is at heart about an hour and a half presentation in 30 minutes. It was kind of a very high level. But I appreciate your attention. I appreciate all of the questions. Any more questions? I know I'm right up against it, if not past it, maybe a minute or two.
All right, thank you very much.
All right.